Hello, Chemistry 100L students. So this is our sixth reaction, reaction F, the magnesium ribbon with the muriatic acid or just hydrochloric acid. It's a binary acid. We learned this naming system. It's an HCl, so we use the chlorine as the root. That's where we get the chlor, and because it's binary, we add the hydro prefix and the ic acid suffix to get hydrochloric acid. So you were given some hydrochloric acid. Now, because we're working with hydrochloric acid, okay, and it's a really strong acid, 1 molar concentration. We'll be learning about molarity next week. As always wear your gloves. And you can't see me, but I got my goggles on, so make sure you have your goggles. So we're going to take the hydrochloric acid. I like to have something to hold my test tube. Usually you have a test tube rack. We don't have a test tube rack, it's fine. Get a 100 ml beaker to hold your test tube. You're going to need your magnesium ribbons, your magnesium strips that were provided. Get forceps, right? I mean, you could just grab it. You're wearing gloves with your gloves, but you can get forceps and grab. What I want you to do is grab one magnesium ribbon for this particular reaction, okay? Now, if we were in lab, I would tell you go ahead and sand the magnesium ribbon to remove the oxide layer so that the reaction is just more clean that way. You're not in lab. If you don't have sandpaper, don't worry about it. If you do have sandpaper though, you can just get the sandpaper and rub off that oxide layer just by taking the sandpaper, folding it over the ribbon and rubbing it off like that. If you don't, no big deal. This is a qualitative experiment. There doesn't have to be anything exact. We are making qualitative observations, okay? We're not doing measurements here. So the reason why I bring that up, it says to add 2 mils of the HCl to your test tube. If you get a disposable pipette, and I'm weird, for all my stuff I label it, so you can see I labeled this because I'll be using HCl again. I'm going to save this disposable pipette so I don't contribute to more plastic in the environment. I know they're disposable, but I label my pipettes. You know, here's my ethanol pipette. You know, I got a water pipette. Yeah, I just keep reusing them because I'm using the same material. But here's my HCl pipette, my hydrochloric acid. When you look at your pipettes, there's a couple graduations. My video is not really, it doesn't do a great job of refocusing, but there's a graduation halfway that's 0.5 mils, and towards the bottom of the bulb, there is a 1 mil graduation for 1 milliliter. You're supposed to add 2 milliliters here. So instead of using a graduated cylinder and having to clean it out, just get one of your disposable pipettes labeled as HCl, fill it to that mark twice, and drop it into the test tube. Doesn't have to be exactly 2 mils. So I'm going to go ahead and do that. I would make sure to lay down a paper towel so you don't want to spill HCl on any surface. It will eat that away. And again, this is qualitative. I'll fill it up to that mark twice. Then I'll discard, and you'll notice that it's stinky, okay? That's normal. Fill it up again. Man, this one's really stinky. I gotta close this up soon, because I don't like the smell. Go ahead. I was always good in lab, but there's certain things that I didn't like in lab, and one of them is stench. So go ahead and close that up. Now I know that's sealed, and my test tube has roughly 2 mils. So the next thing you're going to do is you're going to drop your magnesium, and then you're going to make an observation, and you're going to categorize this reaction, okay? Another reaction we could have done with the magnesium was burn it, but that emits a really bright light. This is a different reaction. It's really neat. We've learned this particular reaction where you add a metal to an acid, and what does it look like we're producing here? The bubbles are an indicator of what? A gas. So this is producing hydrogen gas because magnesium is displacing the hydrogen in the hydrochloric acid so that it can dissolve in solution. You leave this long enough, the magnesium ribbon will be gone. It will completely dissolve unless the hydrochloric acid is a limiting reactant and there's not enough of it to dissolve the magnesium. So the other reaction is optional. I would highly recommend doing it. I'm not going to videotape 15 minutes. I'm videotaping all of this. It's taking me a really long time to do this just because I want everything to be clean for you guys. But you do have that phenolphthalein indicator for that optional reaction. And you can just have another test tube, place it in the beaker, and let it sit for 15 minutes. All right, thanks for watching.